We want to find the equation of the tangent plane to the surface given by z at the point 8, 16, 7. Before we do this though, let's look at this graphically. Here we see the graph of the surface, and now we'll zoom out until we can see the point of tangency in the tangent plane. So now in red we see the point of tangency, and this yellow plane is a tangent plane to the surface. Again, our goal is to find the equation of this yellow plane. So going back to our notes, our first step is to write the equation of our surface in this form here, where we have a function of x, y, and z set equal to 0. To do this, we would subtract z on both sides of the equation, so we can write big F of x, y, z is equal to 7 times e raised to the power of x squared minus 4y minus z equals 0. Next, notice how the point of tangency is x sub 0, y sub 0, z sub 0. So here x sub 0 equals 8, y sub 0 equals 16, and z sub 0 equals 7. Let's quickly review where the equation of the tangent plane comes from. The equation of the tangent plane comes from the dot product of the gradient of f and vector v, where vector v is a vector in our tangent plane. Since the gradient of f evaluated at the point of tangency is normal to the tangent plane at the point of tangency, it must be orthogonal to every vector v in the tangent plane, making this dot product equal to 0. So looking at the equation of the plane, notice how the components of our vector v in the tangent plane would have components x minus x sub 0, y minus y sub 0, and z minus z sub 0. So for our next step, we'll determine our partial derivatives and evaluate them at the point of tangency. So for the partial with respect to x, we'll treat y and z as constants. So the derivative of 7e raised to the power of x squared minus 4y with respect to x would be 7 times e raised to the power of x squared minus 4y times the derivative of x squared minus 4y with respect to x, which would be 2x. So this is the chain rule. And then minus the derivative of z with respect to x, which would be 0. So here's our partial with respect to x. And now we'll evaluate this at the point of tangency. So notice how here we'd have 14x, so 14 times x is 8, times e raised to the power of x squared, which would be 8 squared, minus 4 times y, and y is 16. Well, 14 times 8 equals 112, so this is equal to 112 times e to the, this would be e to the 0, which equals 1, so we have 112 for the partial with respect to x evaluated at the point of tangency. And now we'll find the partial with respect to y, treating x and z as constants. So for the derivative of 7e raised to the power of x squared minus 4y with respect to y, we'd have 7e raised to the power of x squared minus 4y times the derivative of x squared minus 4y with respect to y, that'd be negative 4. The derivative of z with respect to y would be 0. So at the point of tangency, we'd have 7 times negative 4, that's negative 28. And then we have e raised to the power of, again, 8 squared minus 4 times 16, which is negative 28 times e to the 0, or just negative 28. And then finally the partial with respect to z, treating x and y as constants. So the derivative of this first term with respect to z would be 0. The derivative of negative z with respect to z would be negative 1. And of course, at any point, the partial with respect to z would be negative 1. So for the equation of our tangent plane, the partial with respect to x at the point of tangency is 112. So we have 112 times the quantity x minus x sub 0. X sub 0 is 8. And then plus the partial with respect to y evaluated at the point of tangency, that's negative 28. So minus 28 times the quantity y minus y sub 0, or y minus 16, plus the partial with respect to z which is negative 1 times the quantity z minus z sub 0, or z minus 7, equals 0. So again, reviewing the equations of a plane, we just found the standard form of the equation of our tangent plane. If we distribute and simplify, we have the general form. In our homework, though, they want us to solve for z. So now we'll distribute and simplify, then solve for z. So we have 112x minus 112 times 8, that's 896, minus 28y. Negative 28 times negative 16 is positive 448. Then we have minus z plus 7 equals 0. Simplifying, we have 112x minus 28y minus z, and then negative 896 plus 448 plus 7 is negative 441, so minus 441 equals 0. This would be the general form of our equation. Solving for z, we'd add z to both sides, so we'd have the equivalent equation z equals 112x minus 28y minus 441. So this would be the equation of our tangent plane to the surface at the given point, which again, we see here graphed in yellow. I hope you found this helpful.